Hi, algebra students. So we are finishing up our last topic on inequalities that finishes up our unit. And think about where we've been so far, that we have used mostly Desmos for inequalities to graph inequalities on the coordinate plane with x and y input and output, and it creates that region. And then also we have done systems of inequalities, which you just finished up, which involve two. And so today we're going to finish up the last thing, which actually does involve some paper, so you will need your notebook, which you may not have used for a while. But this is really the only thing we're going to write down for inequalities is solving multi-step inequalities. And this is going to feel a little bit like review because you have solved inequalities before, just not multi-step maybe. And so for this particular process, we are still going to be following the DCBA method. So distribute and combine like terms and bring variables to one side, one side, and then always solve. A-L-W-A, that should be an A. Always solve, and I'm not even going to write it using inverse operations because that just means solve it, right? And so we're going to do 4 examples together, and we're just going to remind ourselves what it looks like to solve an inequality, some special rules that are involved in solving an inequality, and then what in the end your answer should look like. So the first example we're going to do, actually we're going to do 4, so if you'll split the rest of your page into 4 equal sections, that will be helpful. And so the first example is 3 and then 7x in parentheses, 7x plus 5 minus 16x is less than or equal to 25. Now, the one thing I want you to notice about this example versus what we have been doing is think about the variables that you see. Everything that we have done up until now had an x and a y in it, and we typed it into Desmos because it was on the coordinate plane because it had x and y. This only has the x variable, and we are going to look at this at Desmos here in just a second, but we're going to use our steps to solve this just like we would any other equation. The only difference is instead of drawing a line through the equal sign, we're actually going to draw our line through the less than or equal to sign. So go ahead and draw your line, and then we're going to follow the steps to try to solve and get x by itself to figure out what x is less than or equal to. So we're going to distribute. So that's going to distribute 3 times 7 is 21x plus 15, 3 times 5, minus 16x still. And then we're going to bring down, instead of the equal sign, it's going to be real tempting to write equals because you're so used to solving equations this way. But we have to remember to slide our less than or equal to sign down, 25. So we've distributed, now we're ready to combine like terms, 21x and negative 16x. And so 21 minus 16 gives me 5x. And then I still have that plus 15 is less than or equal to 25. And then our variable, we already only have one variable on one side. There's no x over here, so we're ready to always solve. And so we're just going to solve it like normal. Subtract 15, you get 10. Slide that less than or equal to down, 5x. Divide by 5, and we get x is, again, slide. Make sure you're sliding down the sign just exactly as you see it. 10 divided by 5 is 2. And so our final answer comes out to be x is less than or equal to 2. And again, it's going to be real tempting to put an equal sign there. Try to restrain yourself. If you get an x is equal to something in the end, you've not carried that that inequality sign down. Now, if you think about what this actually means, this means that the solution is every number less than or equal to 2. And so on the quizzes that you're actually going to do today, you're going to stop right there because that is your solution. You're going to select that. But as we practice throughout the week, if you'll remember, we actually graph these solutions on a number line to represent that this is not just a 2, that this is every number equal to or less than 2. So just very quickly, and again, this should be a review from last year, on the number line, I'm going to find 2, and so I'm just going to put a couple numbers around it. I'm going to find 2. If you'll remember, I circle it. And do you remember what happens if it's less than or equal to? If it's got an equal to sign below it, I shade in that circle. So I circle it and shade it in. And then it's everything less than that. And so the way that the arrow points is the way that I'm going to shade. So I'm actually going to shade all of these numbers. And of course, -1 and -2 and so on and so forth would be done this way. But I'm going to shade that in. And so you will be graphing some things on number lines as the week goes on. Again, just remember, if you have an equal to sign, that circle's filled in. If that weren't there, then of course it would be an open circle. And so paying attention to which way you're shading after you've solved. All right, let's look at another example. So we've got 68 is greater than 2 parenthesis 5x plus 4 in parenthesis. And so again, we're just going to solve like normal. Make sure you draw your line through the inequality symbol to remind yourself that we're going to be sliding down this greater than sign this time. We have to distribute. 2 times 5 is 10x. 2 times 4 is 8. Is greater than, and we're going to bring down that 68. No combining like terms. We don't have any variables on both sides, so we're just ready to go ahead and solve. This one feels a little simpler. 68 minus 8 is 60, greater than 10x, and then divide by 10. And so we get 6, and again, we're just sliding that right down, and then over here we get x. Now, if you'll remember, the final answer is normally written, we like to write it with the variable first. And so if you get to this point, and it's fine to solve it like this, that you get the right answer, in the end, we want to make sure that we're flipping this around so that the x is on the left side and that the number is on the right side. But remember, if we flip that, the sign is eating the 6, if you think about the old alligator analogy. And so we want to make sure that we flip. If we flip our number and our variable in the end, if we have to turn that around in order to graph it, then we want to make sure we turn our symbol around. So make sure you turn that around. And then again, we just want to graph. On quizzes, you'll stop right here. You'll just click on the answer that's x is less than 6. Again, making sure that you've turned that around correctly. But later in the week, if we graph it, we will go to 1, 2, 3, 4, 5, 6. And of course, this one's going to now be an open circle. Because it does not have an equal to sign. So we leave it open, but then we still are shading in the less than direction. So it's everything less than 6. And you'll be provided number lines. So I'm not going to fill in all these other numbers. It's just everything less than 6. And so we want to represent that on the number line. All right. There's one more reminder rule that you've learned that we need to talk about, and it's when we involve negatives. So the next example is going to be 26 minus k. K is going to be our variable here, which changing it up, is greater than or equal to -7 k minus 4. All right, so we have a few more steps here. Again, nothing different though than DCBA. So distribute if you can. -7k, and -7 times -4 is positive 28. On this side, we get 26 minus k. Slide that symbol right down. Now we're combining like terms. There's nothing to combine over here, number and a variable. Nothing to combine over here, variable, number. So now we're ready to bring the variables to one side, which we actually have to do here. I like that this one only has a 1 in front of it, so I'm going to go ahead and just add k to make that 0. So move that over here. So I'm going to add k. And that means there's a 26 left over here. Slide that symbol right down. -7 plus 1k is -6k plus 28. And now I'm ready to solve it because now I have my k by itself. So minus 28 on each side. Minus 28. Oh, something went wrong here. I think this was supposed to be a positive 4 up here in the beginning. I'm sorry, y'all. I'm so sorry. That was supposed to be a positive 4. That was my bad. So we can fix that real quick. So if that was a positive 4, this should have been a negative 28. And then this should be negative 28. I was like, why am I not adding this 28? That should be negative. Does everybody follow that? It's just because I forgot that that was a plus sign. I put a minus sign. So negative 28 and then negative 28. So instead down here, we're going to be adding 28. There we go. My bad, my bad. All right, so we're adding 28 here. So 26 plus 28 gives us 54 is greater than or equal to -6k. There we go. All right, that's canceled out. Now, here is the point at which we have to remember one of the rules. One of the rules for solving inequalities is that if you multiply or divide by a negative number, let me say that again, and let's write it off here to the side. If you multiply or divide by a negative number, not adding or subtracting, it's just multiplication and division, you must do what? Do y'all remember? Flip the symbol. It's just a rule because of the way negative numbers act on the number line, that when you divide by negative, so in this case our last step, right, is going to be to divide by -6, divide by -6. We're going to have to flip the symbol in that case. And so we're just going to flip it around. As soon as you write down, like, hey, I'm dividing by a negative. If you divide by a positive, that's fine. Or if 54 had been negative, it doesn't matter what you're dividing by. If you're dividing by a negative, 54 divided by -6 is -9. And so as soon as I write down that step of dividing, I have to flip the symbol. K is going to be on this side. But now, of course, this one, the K ends up on the right side anyway. So guess what we're going to have to do now? We're going to have to flip it back. But we do have to remember to flip it if you multiply or divide by a negative number. In this case, it does flip back because of the location of the variable. And so K is greater than or equal to -9. And so on my number line, of course, I would find -9. I would circle it. Is this one going to be filled in or open? This one's going to be filled in. And then everything is here is going to be shaded greater than. So everything greater than -9. All right, let's do one more where we have to decide to divide by a negative and we need to flip the symbol. So 3 minus 4 parenthesis z plus 1 is greater than 7. All right, and so again, just DCBA, distribute. Notice here, pay attention, this 4 is not just a 4, it's a -4. We have to take the sign in front of it, so we're going to distribute -4 here. So we've got 3 minus 4z. -4 times z is -4z, and then -4 times +1 is -4, is greater than 7. We can combine like terms. We have a 3 and a -4. So that's -1. So we have -1 minus 4z is greater than 7. -1 coming from 3 minus 4. Take the sign in front of the number. And then we're ready to solve, right? We're getting our z by itself. So now we're going to add 1 to get rid of this. Add 1. We get 8 on this side. Don't forget, and I didn't even draw my line, which you don't necessarily have to, but just keep sliding that greater than symbol down. So we've got -4z. Now here comes the point at which we're going to have to flip, right? Because we're dividing by a negative. So we divide that by that negative number, and we get z is, we have to remember to flip less than -2 because we've done this step right here. Now this one we don't have to flip back because the z landed on the appropriate side. And so z is less than -2, and of course on the number line, this one is going to be, we're going to find -2, circle it, open or closed. It's going to be open because there's no equal to sign, and everything less than that. All right. So solving like normal equations, remembering that the graph is important in the end. Of course, like I said on the quizzes, it will just be this answer, but you will be dealing with graphs later on. Now, I want to show you one last thing because I know someone will ask me, well, what about Desmos? Well, believe it or not, Desmos can help you out checking your answer. Now, I will say it is important for you to go through the steps. So even though what I'm going to show you is going to give you the right answer, just don't forget that it is still important to go through this work. And I know some of you are going to laugh at me and be like, ha ha ha, Miss Wallace, I can type this in Desmos. I'm not doing all that work. And if you do that, you're just shortchanging yourself. So notice if we do type in this and what this is going to look like in Desmos. So if you type in 3 parenthesis, oops, I didn't need that. Parenthesis 7x plus 5. So this is just that original problem that I'm dealing with. Plus 5 minus 16x is, and we do have the less than or equal to's. Why do I have a square root there? No idea. All right, is less than or equal to 25. So notice that Desmos is going to do something, right? Now, if you remember from this original problem, our answer was x is less than or equal to 2. Well, notice what happens on the number line. You are going to get a straight line because there's only one variable here. It's only an x. So it's going to go through the x-axis. And if you click on that, notice it is at 2. It's a solid line, which corresponds with the solid circle here. And it is shaded everything less than that. So you can type this in Desmos and interpret what the graph does as x is going to be less than or equal to 2. So if you can translate between what Desmos will not tell you the actual answer, but it will give you the graph of the answer. And so if you can, it's almost like we've chopped off the y-axis here. And we're just looking at what's on the x-axis. So you can get the number from here, and then you have to interpret solid line or dashed line would be open or closed or open circle, and then which way it's shaded there. So I just want to show you what these others look like what this would look like as a checked answer. So the next problem was x is less than 6. So the original problem was 68 is greater than 2 parenthesis 5x plus 4. And so notice here, it's the dashed line, which corresponds with our open circle, and it does go through 6. So you can get that number 6 from there, and it's shaded everything less than that. I do want to say one last thing. If you come across a problem like this, where the variable is not x, so if you think about Desmos, the coordinate plane only deals in x's and y's. So watch what's going to happen if I type in a k. So it was 26 minus, this is the third example we did, minus k is greater than or equal to -7, and then parenthesis k plus 4. All right, notice what it's going to give you. It's going to say add a slider for k, which you can do, but it doesn't really help us anything out on the actual graph to actually get an answer. What's this doing? This is doing absolutely nothing. And the reason is that Desmos doesn't know what k means. It doesn't know that you're using that as a variable. It's trying to think of a value of k because the coordinate plane only deals in x's and y's. So my suggestion is if you have any other variable besides x or y, actually any other variable besides x, even if it's a y, you need to make it an x. So change all your variables to x, whatever they may be, and you will get a graphed answer. And so remember, for this one we had k is greater than or equal to -9. And so now that's what the graph gives us. It's a solid line, so we know that it should be a closed circle, and then it is at -9. So just remember that about the variables. You always want to be using x when you're typing them in Desmos, and it will keep you from making any mistakes. So that is solving multi-step inequalities. Desmos you can use to help you check. Make sure you're still going through the steps and feel good about distributing and combining like terms and remembering the rules of when to flip and not. And you can go ahead and practice. Make sure you email me if you need help. Thanks.